This in page 5. For those of you who are in the University of Nigeria and Soka, check your continuous assessment. Go to page 5, question 1b. They say find the cube root of this function. Okay, this function of complex number. Okay, z is equals to 1 plus I. We're asked to find the cube root. I know what cube root is. Let's write our solution and get straight to the question. So let's rewrite the question. Z is equals to 1 plus I, right? So since we have to find the cube root, it simply means we should find the cube root, right, of 1 of z. That's exactly all. You can say z to the power of 1 by 3. We can now say z to the power of 1 over 3 is equals to, remember I explained the Morgan's theory just now, 1 plus I all to the power of 1 over 3, right? So in this case, we can find our modulus. Why do I find modulus? Remember in the previous video I told you guys that modulus is equal to the square root of whatever you have from the real part and the imaginary part. So we have 1 squared plus the coefficient is 1 squared, 1 rather, so you did 1 squared. So in that case we have square root of 1 squared is 1 plus 1 squared is 1, so that will be square root of 2, right? And square root of 2, we all know that is something as 2 to the power of 1 by 2. That is it. So I've gotten our modulus. So the next thing to get now is our argument. So the argument is the tan inverse. The tan inverse of what we are having as the function, okay, of z. Remember, forget about this for now. So what you are having is this. So I made a short video whereby I explained this swiftly. So the first thing you take note of is the imaginary part, because that is the sine part. I know tan is sine over cos, so sine over cos. So you have 1 over 1. And the tan inverse of 1 over 1 over 1 is still 1. It's actually 45 degrees. And 45 degrees, you have to express it as a radian. So to express it as a radian, it's now going to be what? It's going to be 45 pi divided by 180. Dividing both sides, dividing both the numerator and the denominator by 45, we have pi over 4. Okay, so that is our argument. Mind you, this is argument, this is modulus. Let me write it here. Modulus, and this is argument. I wouldn't want this video to be too long, so let's make it snappy. So now we want to find, remember we are still looking for the cube root, right? So in that case, let me go straight to the final answer. The cube root in this case is now going to be r to the power of 1 by 3, right? Then multiply by cos theta plus I sine theta all to the power of 1 by 3. Okay, so this is exactly what is going to be. Or we can decide to, this 1 by 3, remember you can either write it as an exponent or you can bring this inside here, okay, thereby multiplying what we have here by 1 by 3. I've already explained it in the previous explanation. That's why I had to explain this De Morgan's theory first. You can see that what we have here, we wrote it inside here afterwards, so we can do that here. So by doing so, now let's write everything at once. Let's incorporate everything at once. So the cube root, right, is now equals to, what do we get before as our modulus? So we have 2 to the power of 1 by 3, so 1 over 2. Then don't forget we have this, multiply by 1 by 3, right? Then multiply by cos, you know that the angle we have is pi over 4, right? So since we have pi over 4, and then I remember telling you that we have to what? Multiply by 1 by 3. So if you multiply by 1 by 3, you put divided by 3 here, okay, because 1 will multiply everything here, then over 3, then plus I sine. Now first you have your pi over 4, then divided by what? By 3. So in conclusion, this would have been our final answer, but I want us to express this. So z to the power 1 over 3 is equals to 2 to the power of, you can use root 2, but we want to use this one, 1 over 6. When you multiply this, then multiply by cos pi over, anytime you have something like this, I don't have time to be expressing it too much. You have it to be pi over 12, okay, because this and this will multiply itself. So pi over 12, then plus I sine pi over 12, and this is our final answer. Let's go to the next question. So the next question reads, what is the principal argument of this? Okay, we have to find the principal argument of this. Solution, we have to find the principal argument. We are going to, let's write the question. 1 plus I root 3. So we are going to rationalize the denominator first thing first. So remember, it's a conjugate. So is a binomial, so we can rationalize. So by rationalizing, the conjugate of this is going to be 1 minus I root 3, and we write the same thing. Rationalizing means you find the conjugate of the multiplier for both the numerator and the denominator. So let's see what we are going to get in turn. To do this down one is going to be very easy. 1 times 1, 1, right? Then plus times minus is actually minus. But then because of we have I and I here, I times I already told you, or let me repeat myself, I multiplied by I is actually minus 1. So since it's minus 1, this will now become plus, okay, because that minus 1 times minus is plus. Root 3 gives us 3. So let's do the up one. 1 times 1 is 1, right? And what we have here is exactly the same. So anytime you have exactly the same thing, I don't want to expound everything further. Anytime I have exactly the same thing, so 1 times this is minus this, 1 times this is minus this. So exactly the same thing, you're going to say minus 2I root 3, right? Because they are minus 2I root 3 minus 2I root 3 twice here, okay? And then when you expand, do this time, you do this. So because of time, we are saving time. So in this case, what is the next thing? Minus I root 3 multiplied by minus I root 3. That will become minus times minus, definitely is plus. But due to the fact that we have I and I here, it's going to now be what? Minus. I believe you are getting me. So root 3 gives us 3. So in conclusion, our final answer is 1. Let's collect the real part first. 1 minus 3. 1 minus 3. Then the imaginary part, the other side, minus 2I root 3. And all over 1 plus 3 is 4. Now we all know that 1 minus 3 is actually minus 2. Then minus 2I root 3 over 4. Right? So we can decide to since we have a denominator here which is 4, we can split it for the both of them. Minus 2 over 4 minus 2I root 3 over 4. So 2 can divide 4 twice. So our final answer is going to be minus 1 over 2 minus 2 can divide here too. So minus root 3 over 2. So this is the standard form, or you can call it rectangular form. But due to the fact that we're actually not doing, they not ask us to find the standard form. What they ask us for is the principal argument, right? Or the argument. Let's talk about argument first. So to get argument, the angle is going to be, remember I told you, tan inverse of, start with the imaginary part, root 3 over 2, then divided by minus root 3 over 2 divided by minus 1 over 2. Minus cancels minus, right? 2 divide 2. What do you have left? Tan inverse of root 3 over 1. Now for one of my short videos that I posted in the short, please, if you have not watched that short, go to my short video and watch it to help you to get your argument very fast. I posted that video yesterday, or will I say yes, that was the last video I posted, and that will be before this video. So tan inverse of root 3 over 4 is actually 60 degrees. And actually 60 degrees, since they say it is the principal argument, this is our answer. But ordinarily, in an ordinary argument, it's going to be 60 pi over 180. This is actually the answer you see in the CA. So 60 here 1, 60 here 3. It's going to be pi divided by 3. But the answer is 60 degrees for a principal argument. Please pay attention to all of this type of argument. For ordinary argument, you leave it ordinarily in terms of what? In terms of pi. But for principle, you leave it in angle. We are asked to evaluate this. Now, this question will definitely come out in maybe your CBT test or exam. So please pay attention. Now, how do we do this? So first thing first, we have to know our indices very well. So this is same thing as E solution. So absolute value of this same thing as E to the power of 2A, right? Multiplied by the absolute value of E to the power of ABI. This is very straightforward. Now, anytime you have E to the power of AB, you get, especially doing it in absolute. So anytime you have an absolute value of E to the power of an angle and I, is actually, I told you that absolute value, like from what I did, okay, absolute value actually is going to have square roots, okay, square root of cos theta cos square theta plus sine square, okay, I sine square theta, okay, and this is equals to 1. This is equals to 1. So since that's the case, everything here like this is equals to 1, and our answer is going to be E to the power of 2A, right? Okay, E to the power of 2A, like absolute value of E to the power of 2A will now become E to the power of 2A times 1, and which is now E to the power of 2A, and this is our final answer. Now the next question goes to us. We have a lot of questions to solve. Now they say we should do this practice question. So how are we going to do this practice question? We have to find, evaluate Z, absolute value of Z plus Z bar. Okay, first thing is, since they're giving you Z, the function of Z, you're going to be substituting it into this modulus. So solution, let's do it straight up. So we have absolute value. So since we have our Z, we're going to put in this minus 4 minus 3i, right? So then plus, they equally ask us to find the, what is it called again? We have to find the conjugate. Okay, we have to find the conjugate of this particular stuff. So that will now be plus minus 4. This minus will now change to what? Plus. Why? Because of the conjugate. So our final answer is minus 4 minus 3i, plus and minus definitely is minus, okay, plus minus 4, then plus times plus is plus 3i, right? Okay, so in that case, this we cancel this, so we have absolute value of minus 4 minus 4, that's minus 8, and the absolute value of minus 8 is actually 8, and 8 is our final answer. 2 of the practice question, we're asked to write this function in Euler's form. Okay, so here are the options which we're given. So let's get right to the solution, no wasting of time. So whenever you have this, let me write the same question, okay, so that I'll start analyzing. So I'm going to first of all find my, remember this is always a function of Z, right? Then I'm going to find these two things, my modulus as well as my argument. So for my modulus, it's going to be the square root of the square of each of these, which is very important. Always find the square of each of these. So square of 2, that will be 2 squared, plus the square of, now if you observe, the coefficient of I now is all of this, so that will be square of minus 2 root 3. And here is how you do this quickly. Square of 2 is 4. Then square of this minus 2 squared is actually 4, right? Then multiply by, this one has root, so root 3 square. Square we cancel square root, so we have 3, right? So that implies that this is square root of 4 plus 4 times 3 is 12. And that is actually square root of what? 16. Okay? And the square root of 16, that means I'm not going to do this one here. And the square root of 16 is 4. So our modulus is equals to 4. Mind you, this modulus is also denoted z. I've said it before. So that's by the way. Our argument, which is always the tan inverse. Okay. The reason for the tan inverse is because of we are going to be doing ratio of sine to cos. Okay, so remember this one should come first. The coefficient of I should come first. Minus 2 root 3, then divided by 2. Definitely 2 will cancel itself. So we will now have tan inverse of minus root 3 over nothing, right? So anytime you have this, just have it at the back of your mind that the tan inverse of root 3 over 1 is actually 60 degrees, right? So it's actually 60. So we're going to be having minus 60 degrees. But then you know that minus 60 degrees is minus pi over. Okay, let's write it so that it will not get confused. That will be minus 60 pi divided by 180. 60 here 1, 60 here 3. So we have minus pi over 3. Okay, so this is it. Now, I'm still going to talk about the agar diagram. So please watch this video to the very end. So, and if you've not subscribed to this channel, make sure you subscribe to this channel. Now, the next thing now is let us compute it in terms of this. Remember, this is called the what? The Euler's form, which has to do with exponent. Remember Euler's to be exponent form. Okay, so in that case, combining everything is now going to be, for the Euler's form, is actually e to the power of theta and I, where this theta stands for your argument. So you have gotten your answer actually, but don't forget that this r here. Okay, let's attach r by the side. So the r is what? 4 e. Then what is our argument? We've gotten it, minus pi over 3. Then attach your I. So which one is the right answer? Option A. Okay, so now here comes the confirmation of our De Moivre's theory. Okay, the Moivre's theorem. So let's go. So we are asked to find z to the 6th power, right? We haven't given the function. We have been given the function root 3 plus I, our modulus, which is square root of each of these. So root 3 squared plus 1 squared. So in that case, root 3 squared, square will cancel square root, we have 3 plus 1 squared is 1. Then our modulus is square root of 4, which is 2. Then going to the argument, how do we find our argument? To get our argument just from what we have here. So start with the one with I. We have tan inverse of 1 divided by root 3. And then check out my shortcut video where I did this. So tan inverse of this is actually 30 degrees, which when you want to convert it to radian, you are going to just multiply the 30 by pi and then divide by 180, right? So in that case, our argument is 30 here 1, 30 here 6 is pi over 6. Now, if you want to write it in terms of De Morgan's theorem, which is writing it in its polar form, here is what we are going to be following. We are going to be following this. We are going to say z now to the power of n is equals to r to the power of n multiplied by cos n theta plus I sine n theta. Then let's use this and then get our answer straight up. So we have z to the power of 6 to be equals to r, which was our r 2. Then remember to the power of 6, right? Multiply by cos. Remember that our n is the 6. 6 multiplied by pi over 6 plus I sine 6 multiplied by pi over 6. And that is the 6 will now cancel 6. 6 will cancel 6. So we have our z to the power of 6 to be 2 to the power of 6
multiply by cos pi plus I sine pi.
Now you know that pi normally is 180 degrees, right? So in that case, for you to say cos pi sin pi, it simply means cos 180 sin 180. So z to the power of 6 is equals to 2 to the power of 6 is actually 64, right? Then multiply by, cos 180 is minus 1 rather. Then sin 180 is 0, okay? Sin 180 is 0. So that means this is gone already. So z to the power of 6 is equals to minus 64. Okay, so this is our final answer, and here we go. So this is it for this video. So if you haven't subscribed to this channel, do well to subscribe to this channel. I will see you in my next video, okay, the part 3 of this video, for other things, not just complex number.